Okay, so the same thing with alkynes. So this time you have ethyne. You cannot have methane, no? Kasi one carbon lang yun. So the only way you can have a triple bond is with another carbon. So same thing with the alkene. You can only have a double bond with another carbon. So ang simplest niyan ng alkene at saka alkyne is a double bond. So you have ethyne, you have propyne, you have butane, and you have pentyne. Okay. So okay. So alkane groups, we call that alkyl. When it's attached to a chain or a carbon, you call that an alkyl group. So when you attach a methane, so the bond with one of the hydrogens will be removed, and then you attach the CH3, that will become methyl. That will become a methyl group. Okay, so that's an alkyl group. So when there's two carbons, you call that an ethyl group, or ethyl. So two carbons, and then you have three carbons. That will be a propyl group. Okay, so that's why you have ethyl alcohol, you have isopropyl alcohol. So that comes from the alkyl group. Okay. So comes from ethane, which you attach to a hydrocarbon. And then C3H7 is propyl. So that you have straight and combine attached to one another. But you have a specialized type of hydrocarbon called aromatic hydrocarbon. So when you say it's an aromatic compound, you have what you call so benzene is a special type of hydrocarbon, which we will discuss next. Okay, but in general, when you have this hexagon like structure, there's a double bond for every carbon alternately. So that's called that's a benzene ring. And then when you see that in a compound, that becomes an aromatic compound. Okay, so another term for aromatic compounds, you call it arene. So when you have an AR attached to a carbon, that's actually a symbol of it's an arene or aromatic structure. Okay. So this formula for benzene, actually, there's a story behind that. It's a unique story. Okay, so it's a mystery to organic chemists, or for most chemists at that time. So you think of the molecular formula C6H6. So how can you construct a molecule made up of C6H6? So there's many isomers, structural isomers that are possible, and it's a mystery. I mean, it's difficult to ascertain which is which. Okay, so the story behind this structure, the benzene structure, this one, this is actually proposed by Kekule. So the story is while thinking of the possible structure of the C6H6, he thought of the carbons as people. Okay, so he thought of them as people. So he dreamt about these carbons, and then these people turned into snakes. So naging ahas sila. And then yung ahas na yon, kinagat nila yung tail ng bawat ahas. So it formed the ring. Okay, so yun yung unique story nung pag-discover ng benzene. Basically, he dreamt of that. And what are the properties of these benzene na compound? Medyo weird kasi yung benzene, because the structures between the carbons are the same. But if we use this structure, maybe based on the double bond and single bond, we would expect the double bond to be shorter and the single bond to be longer. Pero that's not the case. Actually, pare-pareho lang yung length nung carbon to carbon bond sa benzene. So dito pumapasok yung concept ng resonance. When you say resonance, yung structure ng benzene is not actually only the left side or the right side. Basically, what the structure will be, yung double bond kasi, itong double bonds na yan, yung electron na yan, it's moving around. Okay, basically 2 electrons. And then this electron can go to that side, this electron can go to that side. So paikot-ikot lang yung benzene. So that is simplified. Sana mayroon dito. So it's simplified in such a way na pabilog na lang. So instead of the usual na double bonded, na-represent niya yung benzene as a circular thing. Okay, so teka, wala ba dito? Meron akong structure dapat dito ng benzene. Oh, okay, dito yung benzene. Sige, mamaya. Ay, hindi, diduro ko na lang dito. I-annotate ko na lang. So instead of the that structure, ito lang isang structure. Actually, it's a combination of both structure kasi yung electrons nga free to move around. That's why yung benzene can be drawn something like this. So meron kang nandun pa rin yung hexagon ring mo. So sana maging expert kayo sa pagdodraw ng, sorry, medyo pangit ah. Teka lang, pwede ko ba i-erase to? Gawin natin mas maganda straight line. Okay. Yan. Tapos yan. Okay. So you still have the hexagon structure. Tapos meron tayong below. Okay? So yan yung representation ng benzene kasi yung double bond na yan, yung isang bond free to move around. So instead of drawing the structural formula, you can represent benzene as this one. So the carbons represent the corners. And since alam natin na tag-apat yung bonds ng carbon, so ang tawag dito, you can it's implied that the hydrogens are if you count the number of bonds, so carbon is double bonded with another carbon, and this carbon is bonded with one carbon, then matitirang bonds na lang is one hydrogen each. Okay, so one hydrogen each for carbon. So parang implied hydrogens na lang yan. Okay, so that's another representation of the benzene. And this concept of resonance is a concept that we will encounter again and again in the course of discussing this organic chemistry. Okay, so I'll just so the theory of resonance is developed by Linus Pauling, provided the first adequate description of the structure of benzene. So this is the theory of resonance. Certain molecules and ions are best described by writing two or more Lewis structures or structural formulas, and the real molecule or ion is a resonance hybrid of these structures. Okay, so each individual Lewis structure is called contributing structure. So we showed that the real molecule is a resonance hybrid of the two or more Lewis structures by using the double-headed arrow between them. Okay? So, ano yan? Combination ng dalawang structures. So, it's a combination of the two structures, hexagon with the ring in the middle. So, yan ang representation ng benzene. Okay? So, the resonance hybrid of some of the characteristics of each Lewis contributing structure is called the resonance hybrid. So, not just for benzene, we'll encounter that in other structures as well. So, in experiments nga, they found out the carbon-to-carbon bond is equal for all. So, yung actual structure niya is a combination of both. Okay, any questions so far? Walang questions? Okay. Okay, so we have already discussed yung mga Lewis structures na. So carbon, as a hydrocarbon, you can draw that with single bonds for each carbon. Tapos yung hydrogen mo, yan, tetrahedral yung mga drawings na yan, no? So it shows you how the atoms are arranged in space. Okay. So sometimes mahirap mag-drawing palagi ng ganyang karami, no? So what we do, ang shorthand natin, i-combine lang natin lahat ng hydrogen sa isang carbon and we can come up with the condensed formula. So instead of drawing all of this, it will take a lot of time. We have this condensed formula. So sa ibang books, it's called partially condensed. We combine the hydrogens into one carbon para instead of drawing this CH, we have only CH3 that will represent this. So CH3, CH2, 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 CH3. Okay? So yan yung condensed formula. Pero may mas madali. Itong mas madali, kailangan mo i-imply yung mga hydrogen. So hindi na dinodrawing yung hydrogen sa tsaka carbon. Ang mga corners lang, yung edge at saka corners na yan, it represents carbon. So kung walang double bond, ibig sabihin yung carbon yan ay merong based dun sa nakikita mong bond, yung hydrogens na implicit ay madadagdag mo. So for example, yung carbon dito sa dulo, alam mo nakaband siya sa isang carbon, so minus isang bond. That means meron pang tatlo, kaya nga CH3. Itong carbon na sa gitna, meron kang dalawang hydrogens. Kasi nga apat yung bond ng carbon dapat, di ba? So isa dito, isa dito. So the rest are implicit hydrogen. So yan yung dalawa. So 1, 2. Okay? And then yung carbon mo dito, ganun din. So kung may dalawang nakaband na carbon, ibig sabihin hydrogens mo dalawa. So dalawa for this, dalawa for this, dalawa for this. Tapos yung nasa dulo, since one bond lang siya, tatlo. So CH3. Okay? So kahit hindi yan papakita yung carbon at saka hydrogen, dapat ma-deduce nyo kung ilan yung carbon at saka hydrogen. So i-draw lang yung line drawing or skeletal drawing. Okay? So yung isa sa mga kailangan nyo aralin, paano nyo i-convert one into another. Okay? So bakit importante to? Para in your case, 'di ba? Para mas madaling ma-drawing. Okay? Kaysa i-draw for example yung buong it will take time to draw this Lewis structure. Ganyan lang, it will represent 1 2 3 4 1 2 3 4 5. Alam mo agad na pentane siya. So alam mo agad na C5H12. Alam mo na CH3 na sa dulo. So without the need to draw the whole thing, you already know using this skeletal structure. Or sometimes kasi gusto natin makita yung number of hydrogens na remove sa chemical reactions, we also use this condensed formula. Okay? So, dinodraw mo lahat ng CH2, CH3. Minsan, yung iba, since repeating yung CH2, nalagyan na lang ng parenthesis para sabihin na naging tatlo siya. Pero that's confusing, no? Pag ako, in our test, no, pag sinabi kong condensed formula, you should draw all the carbons para alam mo yung connections nila. Okay, another example, this one. So, if we draw the skeletal structure, that will just be 3 carbons, 1, 2, 3, tapos may double bond. So, from this structure, you know na yung dulong carbon mo, since 1 bond lang, the rest will be 3. Tapos isang carbon mo attached to a hydrogen. And then this dulong carbon, since dalawa na siya, ang matitiran mo na lang is dalawang hydrogen. So, even if I draw this, you can come up with this structure. So, that's one of the things you have to learn. Okay? You can write down the skeletal condensed formula, CH3, CH2. Pero sa akin, you draw the double lines para clear sa inyo. Okay? Para hindi confusing. Yung mga double or triple bonds, kailangan nyo pakita para sa akin kung condensed formula siya. Pero madudeduce nyo rin eh. Kasi CH2, tapos may CH ka, ibig sabihin, yung carbon mo, isang bond with yung CH3, the rest will be a double bond. Okay? So what about non-carbon or non-hydrogen structures? Kailangan pakita. So kung di ang carbon or hydrogen, papakita mo yung ibang atoms. For example, oxygen yan. So may double bond ka, tapos yun, kailangan mo nang pakita yung mga bond pairs or or unshared electron pairs para maintindihan yung structure niya. Okay? So again, yung dulo mo, CH3. O ilang hydrogens yun nandito? Dito sa carbon na to.
12, sir, 12.
Hindi, dito, itong carbon lang. Itong second carbon.
Dalawa po.
Itong carbon, meron ka ng 1, 2, 3. So, matitira na lang ay isa na lang. Ito yun ang carbon mo. So, isa na lang matitira kasi nakaband na siya sa tatlo eh. Diba? So, yung carbon na to, may 1, 2, 3. So, ang isa na lang bond ang kaya niya with hydrogen. Yung mga dulo as usual, ilang hydrogens ang attached dyan?
Tatlo po.
Tatlo po.
Okay, so may tatlo. So, tatlo dito, tatlo dito, tatlo dito. Itong carbon na to, ilang hydrogens ang attached dyan?
Isa lang po.
Sure ka na isa lang? Bibilangin niyo yung bonds. 1, 2, 3, 4. Kaya pa ba mag-bond ng hydrogen? Wala na, di ba? Kasi apat na siya. 1, 2, 3, 4. So, dito sa pangalawang carbon, 1, 2, 3. So, kaya pa niyo mag-bond sa isa. Dito wala na. Okay? So, tingnan niyo yung number of bonds. Any questions? Do you have any questions? So, let's try to do, kaya natin mag-annotate dito. So, try natin to. So, ang dodraw ko to, 2, 3, so, anong klaseng hydrocarbon yan? Ano yan? Alkane, alkene, or alkyne?
Alkyne po.
Alkene.
Alkynes po.
Alkyne siya. So may double bond ka. So ano magiging formula niya? Molecular formula lang. So carbon at saka hydrogen lang. Okay, who can guess? Formula, yung molecular formula niya. Ano ba yan? C3H10 o C7H14?
C5H10 po.
O C5H10 kasi alkene siya. So carbon, may CH3 ka dito. So paano yung condensed formula nito? You have drawing pala to. CH sorry sa text na lang kaya. Text na lang mas madali. So, ang formula ko dito will be condensed formula will be CH3. Dapat ang tawag dito subscript CH2. Okay, CH3, CH2, CH2, tapos CH1, CH2, CH2. Dito, carbon mo naka-double bond. So, isa na lang. Okay, so matitirang hydrogen ay isa lang. CH. So, pwede ko i-represent. Papakita ko yung double bond para clear. So, yan, may double bond. Tapos naka-attach dun sa dulo, CH2. Okay. Okay, so yan yung condensed formula. Okay, gets nyo? Kuha nyo? Any questions? Clarifications? Kasi dito sa sa biochemistry, instead of drawing everything, hindi kaya natin i-drawing lahat, no? So we will resort to drawing the skeletal or line drawings, line structures. Nakuha nyo ba? Ito parang shortcut pag nagdo-draw tayo ng skeletal or line structures, shortcut siya kaysa i-draw yung buong molecule. Any questions? Too much information? Parang tahimik lahat. Nagets ba? Hello?
Okay naman po, sir.
Okay, so nagets. So I'll stop. Okay. Okay, so meron tayong ball and stick model, no? Sana by the time we get to the lab, nagpabili ako ng mga ganyan. Kung wala pa hindi pa dumarating yung in-order ko na ganyang model, pwede kayo magdala ng parang ping pong balls or styrofoam. Pero ang kasi nasa styro, environmental tayo, we need to be environmentally friendly. So kung mayroong ibang option, alam ko may paper mache, no? Kaysa maggumastos pa kayo sa styrofoam. Yung ibang mga yung mga old papers, pwede mo yung may form, meron yung meron yung ingredient sa YouTube eh. Paper mache, hanapin nyo. Paper mache, pwede kayong gumawa ng parang models, mga bola, tapos mas tipid pa kaysa bumili pa kayo ng styrofoam. Okay, pero we will use this para makuha nyo kung bakit importante yung mga angles, no? Yung mga, yan, kita nyo na tetrahedral, yung sa ball and stick kasi makita mo talaga lahat. Yung white, so kita nyo yung angles ng bawat isa. Pag gumagawa line structures, ganyan yung representation, pag condensed, ganyan naman. Okay, so pag complete structures, ganyan, no? Lewis structures, ganyan yung representation. So we can condense that to CH3, CH2, CH2O, H. Paano yung yan? Paano mangyari? Sino makaka-draw ng dyan? Ng line structure niyan. I-draw niya dito sa side na to. Pwede naman. Oh, Daphne. Okay. Yan yung complete structure. Paano yung, hindi, kung line structure lang, yung pinakasimple lang. Medyo complicated na yun. Mag-erase, teka lang. Mag-erase tayo. Para simple, anong mangyari dyan kung simple? Kung simple lang yan, so 1, 2, so kung line structures gagawin natin, 1, 2, 3, and then saan na tayo maglagay ng OH. Okay, so pwede yan, no? Kasi nakaband sa, hindi masyado malapit, no? Pero mas malapit dapat yung band. Pero ito, nakakabit dapat yung oxygen dun sa line. Pero yan yung carbon, carbon, carbon. Alam niyo na CH3, CH2, CH2 yan. Okay? Pag condensed structure, yung papakita mo yung N. So kung line structure to, it will just be, ito I will be, tanggalin ko na yung text. Dapat line. So this will be